Okay, so this is the first session here on modeling and control. So modeling and control 1. This is the auditorium. And we have 5 speakers lined up. And we start with Uwe Fechner here on Airborne wind energy simulation software. A review. I think it's very fitting to this session because Uwe has done many years, more than a decade of research in airborne wind, and he knows definitely what is around, and I'm very curious to hear the status. Thank you, Uwe, please.
Good morning, everybody. So my talk is Airborne Wind Energy Simulation Software, a review. First, I will give an overview. What is the purpose of Airborne Wind Energy Simulation Software? I present some historical simulation software that cannot really be used anymore, but might be interesting to look at for some researchers. And then I present the current simulation software that I'm aware of. The scope is only open source software, mainly for dynamics simulation, with one exception, using quasi-steady simulations. Then I will give detailed descriptions of the mentioned 5 different simulation softwares, and then I draw some conclusions and give an outlook. So what are the applications of airborne wind energy simulation software? For me, important is the educational purpose. So I want to teach students about airborne wind energy. I want to be able to explain how RWave works. That's not only important for students, but also for investors. It's nice if you can easily explain how it works. And also to learn the impact of changing parameters. So how much energy can we harvest if we are allowed to fly 100 meter high? How much if we are allowed to fly 300 meter high? This should be easy to answer questions using simulation software. Then controller design and trajectory optimization. If you want to design a controller, most likely you need a model. And the same holds for trajectory optimizations. Then the wing designers want to know, what is the impact of the changes they make. Is it more important to have a high CL, or more important to have a low CD, or what is the impact of the inertia or the weight? For ground station design, it's also important. We need to know the maximum reel-in speed, reel-out speed, forces. The impact of the efficiency. Some people think if the ground station is 80% efficient, then you get 80% of the energy out. But that's not true. If you work in pumping mode of operation, you get less out. So high efficiency of the ground station is more important than for wind turbines. And then also for wind resource assessment, simulation software is very useful. So this is an overview about historical AV simulation software. The first one is KiteFast. KiteFast is a simulator for airborne wind energy systems based on the OpenFast whole turbine simulator. So OpenFast is the standard for conventional wind turbine simulations, in the open source field. And KiteFast, there was funding, I think it came from Makani, to develop an airborne wind module there. And that is finished to 80%, but it's not finished and it doesn't work. And it's Fortran, and not many people can program that. Then we have Kite Power, wind energy harvesting with reinforcement learning. That was more or less a master thesis project, and it's nice to look at, but it cannot even fly power cycles, so it's quite limited. Then we have the Makani software, a huge package of software, everything open source. Yeah, I say it's historical because you can only run it in a virtual machine. It's no longer maintained, and it is specialized on the Makani wing. So of course, because it's open source, you can say, I try to reuse some parts of it, make a fork, and update the dependencies. Yeah, it's possible, but so far I think nobody did this. And then we have OpenKite, a ROS package for simulation, estimation, and control of rigid wing airborne wind energy kites. I think it's from Switzerland, from the university. But very nice software, but development stopped 6 years ago. And yeah, I'm not sure. Sometimes people leave and then leave something that doesn't work anymore. So now we come to the current software. That's a lot less. There are 5 software packages to be mentioned. I start with Avera, which is a quasi-study kite power model with wind profile clustering for resource analysis. In the moment, it is quite specialized on lead edge inflatable kites, but it could be easily also extended for other systems, so that might be interesting for some of you who work with rigid wings or whatever. If you want to do wind resource analysis with systems that have another power profile, please look at it. Then we have RV-Box, modeling and optimal control of single and multiple kite systems for airborne wind energy. A very nice piece of software from Freiburg, and it's under active development. But I think, again, focused on rigid wings, but on very different configurations, dual kites, multiple kites, all kinds of rigid wing systems. Then we have Kite Simulators GL, simulators for soft wing kite power systems. That's my own software written in Julia. I presented it on the last conference. Then we have Mega Aves, MATLAB Simulink model of a megawatt class airborne wind energy system based on a rigid wing technology. I find it a bit problematic because Simulink and Git are not the best friends, but it made good progress in the last years, and there's a huge consortium trying to improve it. And then we have a kite dynamic simulation model from the US. It was originally developed for underwater kites, but it now also works with all kinds of airborne wind energy systems based on Simulink. So yeah, probably accessible for university people, but not so much for others. Now some detailed descriptions. Avera, you see on the link left-hand side this quasi-study model results of the flight path for different wind speeds. And it builds on the wind profile clustering techniques used by Mark Schellbergen from TU Delft. RV-Box, they have very nice graphics, and you run a script and then you get nice results. A little bit difficult to install because you need some proprietary solver, but it works if you are a bit patient, and advanced flight path optimization and multiple kite systems. Kite Simulators is my own software, easy to install also for students. It provides Julia kite power tools. I have separate packages for guide, ground station, environment, etc. So you can improve any of them separately. So if you need a ground station model, you just check out that project and adapt it to your needs. And it's very fast, so 66 times real time now on my laptop. It's currently only for soft wings and easily to install and to extend. Improvements since the last conference. I'm using now the new Pure Julia DFBDF solver, which improves speed by a factor of 2 and reduces the error by an order of magnitude. And the flight path planner code is simplified. So my original code was very hard to understand and to change. And I tried to remove all hard-coded constants and now have a learning script that learns the corrections for a specific kite. But that needs further improvement. And I improved the GUI plotting and logging, so you can just really run the GUI and load a project and run the simulation. We have MagRVES, a MATLAB Simulink model of megawatt class Airborne wind energy systems. A lot of improvements happened from a PhD colleague in Delft and others in the last year. We have an advanced controller and a realistic wing model. And kite dynamic simulations, that's the new thing in the work group. We are also offered training. So if you want to have a training how to use this software, just contact one of the guys, Chris, preferably from the US, and he will invite you when there's an online training.
1 more minute.
Conclusions and outlook. Depending on the requirement, different model simulators are needed. 5 simulation packages have been presented that are under active development. 3 for dynamic simulations of rigid wing kite power systems. 1 for soft wing kite power systems. And 1 package for wind resource assessment for soft wings. Missing a simulation package for dynamic simulations of rigid wing kite power systems that does not require any closed source licenses. Simulation software for soft wings, pulling ships and for kites other than lead edge inflatable kites. And wind resource assessment software for rigid wing kite power systems. So if you want to, I can show you the newest version of my software in the break, and you can play with it. Thank you very much.
We have time for 1 or 2 questions maximum. Are there any questions? Yes.
Thank you for the nice presentation. What would, from a user perspective, now if you used all of these different packages, what were like the major working points or shortcomings that you experienced as a user in these packages that developers could improve?
Wait a second, I have to repeat that for the online audience. So the question was, from a user perspective, what are the major points of improvements now in these software packages?
I mean, one issue is the version dependency. So all these software depends on some other packages. If you use MATLAB Simulink, you need to install the correct MATLAB Simulink versions and then the required toolkits. And that's actually not even documented, which are needed on the GitHub page. And with Python, it happens, it works now, and a year later it doesn't work anymore because some packages have updated. And then you need to write a bug report, and then hopefully it gets fixed. So these, and then if you have the running software installed, then of course you need to install to understand how to run it and what is the input format. Normally I would expect there is a standardized input format and a standardized output format. This is not the case, but that is something we are working towards.
Thank you. One more question, or even 2. We go for here, and you ask later in the break. so the question was about MATLAB Simulink, which is commercial software and it's quite costly, and that is an issue.
Yes, MATLAB Simulink is easy to get started with, but as soon as things become a little bit more complicated, it becomes a mess. So I also started with it 14 years ago, and I switched then first to Python and later to Julia, and it's much more fun. And my Julia simulations run 1,000 times faster than the MATLAB Simulink simulations, which might be relevant for some optimization tasks. But until now at university, often you learn MATLAB Simulink and you do not learn Julia, so there's an entry barrier.
Thank you very much, Uwe, for this talk.